Good afternoon, everyone. Thank you for this introduction. My name is Ram Dayal Yadav. I'm working as Associate Research Fellow at Carbon Nexus Deakin University. So, before starting, I would like to convey sincere apologies from my supervisor, who was supposed to present these slides, but somehow she was not able to make it. So basically, I work on the development of low cost precursor for carbon fiber applications. So I'll start with first what we are actually at Carbon Nexus. So Carbon Nexus is a unique facility in the entire Australia where we work on a number of precursor for the development of carbon fiber. We have a huge facility combining a research line, and we have on a pilot scale line. On the research line, we go up to like from 3000 to 320 to K2 size we can process in our Carbon Nexus facility. We are even equipped with a lot of characterization tools with especially focused on the carbon fiber applications. And then if we really want to process less than 3002, we also have a facility called carbon fiber simulator. Actually, this carbon fiber simulator, we normally use it for feasibility study. Let's say if we are developing some new precursor, and definitely for running the research line and the pilot line, we require a lot of precursor fiber. But for just simulating the stabilization parameters and carbonization parameters, we normally use the carbon fiber simulator, which we can use any toe size, like from 300 filaments to 3,000 filaments. So these are the some facilities in the Carbon Nexus. So I'll start originally the presentation what about so if you see the carbon fiber definition, so carbon fiber is a fibrous form of a carbon which is having at least 92% of carbon in it. So if you see the carbon fiber application nowadays, like a lot of weight loss, and in the field of automobile or electrifying the automobiles, everything is we are talking these days. So these carbon fiber applications are getting every day, increasing every day. The main application is basically wind blades, aerospace, sports, automobile, and some form of the construction. So if you look the market of the carbon fiber, it's continuously increasing, and it is expected to increase further. So if you so there are a different type of a carbon fiber available. So it is high strength fiber, high modulus fiber, and an intermediate. I will not go into much details of what basis of the definition of these type of the carbon fiber, but in generally they are defined in a four to five different forms. And then if you look into the carbon fiber manufacturing, so three major sources, precursor materials are available for carbon fiber manufacturing, which one is polyacrylonitrile, pitch, and rayon. So the entire process consists of like first we produce the precursor, then stabilize it, carbonize it, and then finally comes with the carbon fiber. Overall market, if you see the carbon fiber market, if you see, so it is fundamentally dominated by polyacrylonitrile. So polyacrylonitrile, if you look into the market, 90 to 95% of the carbon fiber market is covered by polyacrylonitrile. Pitch comes the second. Rayon is almost like it's not used at all nowadays because the final carbon content is very low in the rayon. So if you like overall, if you talk the challenges, like why we really need to replace the pan or reduce the cost of the carbon fiber manufacturing. So major challenge comes from the pan precursor material cost. Overall, the cost distribution, when we have one small project with Ford US, where we have done the in-depth analysis of the production of the cost analysis we have done. We have developed our own model, which is like considering each and every aspect. Since we have the pilot line, we have also validated this model. So based on our model, we have identified that around 50 to 53% of cost comes from the pan. So definitely, and the second most important reason for replacing pan, if you see in the COVID, this situation in the COVID, the supply chain is completely disrupted in every sense of our life. And pan is a petroleum product. So definitely looking at the situation, and since we are moving away from petroleum fossil fuels, and we are moving towards net zero technologies, so definitely this is not going to be a sustainable source for such an important and commercially important material. So we need to look into some kind of alternatives. We need to look into what kind of alternatives are possible, where we can either replace or reduce the cost, or we can find um, a sustainable solution for this. So if you look into a lot of options, so lignin was considered to be one of the prominent material which where we can develop a precursor material. So I will not go into what is lignin and how lignin is produced, but in generally lignin is, if you see that it is a second abundant material after the cellulose, and it exists with cellulose and hemicellulose by providing the structural stability to cell plant. This project was funded by Ford US for their automotive application. And this year we have finished this project, and this we have done this on a research line. So the catch in this project was, if you see any lignin papers or any lignin projects, they normally do it on a lab scale. We have done it on a pilot scale. So we have produced around more than around 500 meter to 1 kilometer of continuous fiber out of lignin. And we have done the cost analysis also. We have shown that by using lignin, we can reduce the cost by 25%. We are further moving ahead, and we are very pretty sure that we can even further reduce the cost. This project is this year it has finished. We are continuing for the next year. So we are looking for some better and more satisfying solution coming out of this projects. And then we were looking for second alternative for carbon fiber development, which is called asphaltene. Actually, this project was funded by Alberta Innovates. They are a petroleum based company in Canada. So Alberta, we have finished the phase 1 last year, and this year we are granted with the second phase, where phase 1 was the feasibility study. Basically, in the phase 2 we are working on large quantity of carbon fiber development from the asphaltene. So what is asphaltene? Basically, actually in Canada, mostly oil comes in the form of a sand, which is a combination of bitumen and water and clay. So these bitumen, actually asphaltene is a leftover of the bitumen. It is a waste basically. So they are looking for some solution, what that waste, and they are piling up with millions and millions of tons of waste coming out of bitumen processing. So we proposed that we can try the carbon fiber manufacturing, because this asphaltene basically is having a very high carbon content. The asphaltene which we have received from Alberta is having a carbon percentage more than 80. So we believe that definitely it is going to be a good source, and you can see that we have produced the carbon fiber from it. Though in the phase 1 it was a very small quantity, but in this current phase we are looking for a production of a large quantity. So asphaltene, we have looked into another sustainable source for producing carbon fiber. And then we have one more project with the carbon innovation, and with the collaboration with the Monash University. So in that project we have used brown coal lignite basically. So uh, what happened, like in Australia, basically the main source of electricity comes from the brown coal. So definitely if we are promising for a net zero future, so definitely we need to look for some other option where the waste of those materials can be utilized for some value added application. So this project we have tried, we were trying to produce. So basically this entire process comes from fiber extrusion, then winding, wet spinning, and then carbon fiber production. We have successfully produced this. We were very much successful in producing this carbon fiber out of this lignite project. And We wanted to have a further expand this part, but we are still waiting for the next round of funding. So this is three basic precursor material which we have used in our projects, and we are looking even further. There are a number of projects we are doing on number of other alternative materials. So what I just summarize and the challenges which what we are facing. Definitely the first challenge is like whatever alternative materials we are using, we need to reach the pan precursor quality, which is one of the biggest challenge. Second thing, any natural material you take for replacing a man-made material, the first problem comes with all the natural material comes with some extra functionality. There will be some ashes, there will be some metal traces or some impurities. So all these alternative precursor needs to have some purification and modification methods. So before coming into the main source for developing precursor, it has to be modified or it has to be purified in some way, some form, either chemically, mechanically, thermally. So this is one of the challenge, but with the course of time in last 1 decade, there are a lot of advancement has happened in the processing. A lot of companies are now coming into providing per se like lignin. A lot of companies are providing fibrous quality lignin nowadays. So now things are progressing. So we are very much hopeful in the coming time they will be able to get something which will be definitely challenging the pan-based carbon fiber. So this is a hope, and this is what we are expecting. So in the acknowledgement, I'll definitely, I would like to acknowledge DKIN, ANFF. They have supported us for some kind of instrumentation in our IFM labs. And if you have any questions, thank you for your attention. If you have any question, please go ahead and ask. Thank you.
Good afternoon, Ram. Thanks. That was really, really fascinating. We actually had a few quick questions.
Yes,
the first from Jane, which is, how do you actually find these cooperative projects? You've mentioned 3 quite fascinating and very different projects. How did those come about?
It's a good question. My supervisor would have given the right answer, but actually, we were having a long relation with the Ford and Alberta Innovate. So once they know our background, we know their background. They come up with some idea, so they have shared with us, and then we wrote some proposal, and then this is how it go ahead. So it's actually a long relation with the company which help us in getting all those fundings.
Thank you very much. And the second one's from Kate. What is the criteria used when considering whether a material makes a good precursor?
Good precursor. Okay. The criteria is basically the first thing we first compare with the pan. Like there are a number of spinning methods. If you go with the wet spinning, melt spinning. So normally we compare with the pan what properties pan should be, because carbon fiber property is driven by the precursor property. So we basically, our benchmark is pan. We compare with that. We first process it, produce it, compare with the pan. If it is okay, and at least 80% of the pan property, then we go ahead with the processing, stabilization, and carbonization. Otherwise, we don't go ahead.
Thank you very much, Ram. That's very, very useful.